Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope you all are doing really great. So students, in this video we are going to solve the question from the chapter atoms asked in a JEE 2024 exam. Okay, so let's see the question. So the question is here, see, when a hydrogen atom going from n equal to 2 to n equal to 1 emits a photon, its recoil speed is x by 5 meter per second, where x equal to how much? Okay, so here remember that one thing, as the hydrogen atom is at rest, is it? So here try to understand please. Now this hydrogen atom is at rest, that means its initial momentum is how much here? 0. Okay, so what happened that, let's take this hydrogen atom is got excited, is it? So when it will got excited, what will happen that here? It will emit the photon. So this photon, let's take this photon is going in this direction with some speed c, no? Because photon always moves with the speed of c. Then what will happen that here, to conserve the momentum, what will happen that here, this hydrogen atom will experience one velocity in this direction, is it? So what will happen that here, let's take mass of hydrogen atom is mh and this is vh, no? Velocity of the hydrogen atom is how much here? Vh. Okay, should be equal to mass of photon into speed of photon. Okay, and to conserve the momentum, what will happen that here, they will move in a which direction? Opposite direction. So what we can tell, initial momentum is 0. So here also what is happening that here, remember that here this final momentum is also 0. So to make the final momentum 0, what will happen that here, students both will move in a which direction? Opposite direction. Okay, so only we have to just calculate this recoil speed of the photon, is it, to conserve the momentum. Okay, so here we have to use one basic, remember that here, you know that very well, delta E equal to h into nu, is it? Or we can write here, see, h nu is equal to delta E, or we can write here E2 minus E1. What is E2 minus E1? You know very well, E equal to minus RHC z square by n square, and hydrogen is there, that means z equal to 1. So we can write here, remember that here, this RHC, z is 1 only, so we can write here 1 by n1 square minus 1 by n2 square, even very common second postulate of the Bohr model. Okay, after that what will happen that here, see here, this delta E is what? Energy, is it? That only I have written here h nu. Okay, so here what will happen that here, you know the relation E equal to mc square, is it? Or if we want to write here this delta E in terms of the momentum, is it? So we can write here this momentum of the hydrogen atom into c, now because E equal to mc square, from there only I am writing here this energy, we can write here momentum of the hydrogen atom into c is equal to what we can write here, see here, RHC 1 by n1 square minus 1 by n2 square, is it? Remember that here, very basic, to calculate the recoil speed. After that what will happen that here, remember that, see here, this we can write here, momentum is what? Mass into velocity, is it? So see here, mass of hydrogen atom into velocity of hydrogen atom will be equal to what? This pH I have written, mh into vh is equal to, I can write here, see, RHC, and here 1 by n1 square minus 1 by n2 square, and this by c will be there. Okay, this by c will be there, na? This c is there, na? That will go this side. Okay, after that what will happen that here, you are thinking I will cancel c and c. No, I will not cancel c and c. Why? Because RHC value is there. RHC value, what is this, you know, 13.6 electron volt. How much RHC value? 13.6 electron volt. That means 13.6 into 1.6 into 10 to the power minus 19, and c value how much here? 3 into 10 to the power 8, is it? And this one as it is, 1 by n1 square minus 1 by n2 square. After that, see, the main game starts here. Okay, so what will happen that here, see, if I write here, this recoil speed of the hydrogen atom is given by what? We have to just do the calculation here. Okay, so what will come here, see, this 13.6 into 1.6 into 10 power minus 19 by, what is the mass of the hydrogen atom is given here, you can see very well, 1.6 into 10 to the power minus 27. Okay, into, and you can see very well, 3 into 10 to the power 8, this is here, and you guess please what will be n1 by n1 square minus 1 by n2 square. See here, n1 I will put here this one here, this will be the n1, okay, and this will be the n2, okay. So we can write here 1 by 1 square minus 1 by 2 square, so it will become 1 minus 1 by 4. That means we can write here 1 minus 1 by 4 means we can write here 3 by 4, is it? After that we have to cancel the things here, okay. So what we can do here, see, this 1.6 is cancel, is it? From this 3 is cancel, is it? After that we have to just see here 13.6 by 4, see here 13.6 by 4 into, let's write here the powers and also see, minus 27 plus 8, that means 10 to the power minus 19, is it? Minus 27 plus 8, how much here? Okay, minus 19 only, so 10 power minus 19, 10 power minus 19 also cancelled here, is it? So see, 10 power minus 19 by 10 power minus 19, both is cancelled, okay. That means it is coming here 13.6 by 4, okay. So if I will cancel out here, see here, if I remove the decimal, it will come here 136 by 40, okay. So now after that here we can cancel with the 8, we can cancel, just see, 8 1 ja 8, 5 is there, okay, we can cancel, see here 8 5 ja 40, and here we can write 8 1 ja 8, this 56, 8 7 ja 56, so what is coming here, we can write here 17 by 5 meter per second, is it? So here what they are telling that here they are telling x by 5, okay. So what is the value of the x? The value of x will come here 17, is it, students? So see very well how I have done, very well how I have used this Rydberg formula to calculate the recoil speed of the hydrogen atom, and this is based upon the conservation of the momentum. So students, I hope so this video is very clear to you. Keep studying, keep growing.